Hello everyone. In the last episode, we discussed the Coulomb's law of force, how the quantitative aspect was there present between the interaction of the two charges. And then we found out the vector notation and how the Newton's third law of motion was evident there. Today, in this episode, we shall be dealing with a very mysterious force all around the charges. It was considered to be a mystery since the many of the centuries back again. But then some of the guys from the world of physics, they solved it just like a simple puzzle. Yes, today we shall be discussing the concept of electric field, how it affects the charges and what it is exactly. Now, suppose there are two charges in an empty space. Well, how the one charge will know if there is some other charge present there? If I have got two charges just like this pen and its cap, suppose they are kept here. Now, how will this cap knows that there is a pen in the space around me? Have they got some sort of messaging services? Well, absolutely not. But still then they have got some sort of communication. So what is that communication? You must have read the Coulomb's law of forces. There is a charge, say Q, and some smaller charge, say small q. So when the small charge comes closer to the bigger charge, that is q, what will happen? The bigger charge, depending upon the magnitude of the smaller charge, will either repel it or will attract it. This is really very fine, right? Because we know the Coulomb's law of force. But just imagine what will happen if I remove the smaller charge. So is the charge q all alone in that space? Is there nothing around the charge q? Actually, there is not like this. The condition is a bit different. If nothing is left, then how can a test charge q, that is a smaller charge q, get affected by the bigger one? And if something is there, then what is that something? This is we have to find out in the coming pages of the book called Electrostatics in Our Daily Life. When I opened up the pages of this book called The World of Electrostatics, I found something that around every charge there is something that is responsible for the interaction of the charge with the other ones. That is, if there is a charge, say A, then around that charge A there is something that is responsible for the charge B coming around that charge A. Well, we all know the Coulomb's law of force. There must be some sort of force that will act between the charge A and B, provided the distance is r and something, all things like that. Now, if I remove the charge B from there, or if I remove the charge that is coming into the picture with the charge that I have placed somewhere, what will happen? The charge is gone, but the force still has some impact. Okay, you are a bit doubty, right? So let's remove this doubt by a very simple example. If I follow the Coulomb's law of forces, and if I have got two charges, say q1 and q2, and r being the distance between the two charges, then what will happen is that there will be some force that will be F is equal to k times q and q divided by r square, where r, for simplicity, we have considered that k is equal to 1 by 4 pi epsilon naught. Now, if I remove the charge q from this whole picture, what will happen? The force will get divided by the charge smaller q, and then something will come out whose magnitude or whose value will be simply k times the magnitude of the charge, that is q, and the smaller q gets cancelled, divided by the distance between them, that is r square. So this entity is nothing but k times q by r square. What is this? Actually, this is the electric field. Yes, this electric field is responsible for the behavior that is shown by this charge capital Q towards the incoming charges. Well, what I have drawn here is nothing but I have considered a charge the bigger Q, and you can clearly see that there are some lines going outwards, because here I have considered that this charge Q is positive. So, it is some sort of repulsion, that is, if I bring any charge, say if I consider this rubber as a charge, and if it comes closer to it and the rubber is positive, what will happen is that this shows that it is to be repelled by it. If it comes from this side, it will get repelled. No matter from what side it comes, it will be repelled, because both of them are positive. If it is positive and this rubber is negative, it will be attracted and this arrow will point inwards. In this picture, what I have done is nothing. I have simply drawn it a bit spherical by rotating it. So, what we can conclude from here is that no matter from which direction a charge is coming, from this direction or this direction or this direction, if the distance remains same, then exactly the same amount of force will be experienced by the incoming charge. This gives rise to the spherical symmetry. Yes, the concept of spherical symmetry is clearly evident from here. Now, after discussing the mathematical formulation or what an electric field exactly by going through the Coulomb's law of force, I just wanted to know one thing, that what is the means that how is the electric field around me? If electric field is there, it should be around me. I should be able to visualize it. And for this, I am going to give you a very simple example that will bridge the gap between what we have seen and what it is. That is, I will provide you with an analogy in this world. For example, if I am going out to play with my friends in the evening, I am a free charge. So, I will go anywhere wherever I want. But by the dawn, if I come back to my home, what will happen is that once I enter my home, the authority there, that is my parents, will try to govern me. Actually, they won't try, they will govern me. So, this concept of electric field is just like the authority that we have in our home. If I am near to my home, I will make sure that I don't shout, I don't misbehave, and I keep all the things neat and clean. And once I enter the house, I have to follow the rules given by the authority. Well, this is the same case with that of the charge. If there is some charge, that is B, and it is roaming around freely, no one to interfere. But when it comes into the surrounding or into the vicinity of some charge, say A, which is bigger and which has got more power or authority, just like our parents. So, what will happen is that the charge B will have to follow all the rules and the guidelines given by A, that is, it will have to follow the electrostatic law of forces. So, if the charge A is positive and the charge B is positive, the charge A will say, go away from me, that is, there will be some repulsion. If charge B is negative, charge A will say, welcome to my home, you are most welcome, please come here, because there is some sort of attraction. So, why I am telling you this is that because we all need some sort of analogy in our day-to-day life. So, please don't think that this electric field is only a concept in the world of electrostatics. It is all around us. The only thing is that we have to feel it. Now, what is the physical significance of this electric field in the world of electrostatics? That is, in the real world I have seen, but if I go back to the electrostatic world, what is there in it? The first question that arises here, that why do I need E? E stands for the electric field. What is the need of simply saying that there is some electric field around a charge? Well, the need is that electric field of a particular charge characterizes the electric configuration or the electric environment of the system of charges. That is, how the other charges will behave in the vicinity of a particular charge, say A, is determined by the electric field of that charge A. Also, if I consider that every charge is of unity, that is, if every charge is of 1 coulomb, then that will tell me, that is, the electric field will tell me the amount of force that a unit charge that is brought into the vicinity of some positive charge to an extent, that is, to what extent a unit charge experiences force by the charge that I have considered. Also, the third and most important point that I must have in my mind is that the electric field is completely independent of the test charge. The problem is that we all think that if there is some electric field, say of a charge A, and if a charge B is also coming, so we will think that the electric field is dependent upon the charge B. Well, that is not the case, because what we have discussed earlier is that the electric field is the characteristic property or the authority or the power that it holds in the vicinity or the surrounding of the charge A. So, no matter whether charge B is there or charge C is there or there is no charge at all, the electric field E will still exist. Now, after discussing the analogy that I can find in my day-to-day life with the electric field concept, we must also consider what is exactly E in the context of the electric charges. What was the need of the scientists to introduce this concept of E in our life? We will take an example to show that it is always there. For example, if I have got a charge, say this rubber, that is charge A, and if I have got this charge B here, the cap. If this is positive and this is positive, you will say this will repel it, and the same will happen for this one with this one. That is quite sure. But there is something that is going underneath that we are not able to see. That is, for the first thing that we should consider is that the light speed, that is the speed of light, c, is the fastest that can be achieved by anything. Well, not even achieved, that is somewhat similar to it, we can achieve, near to it. So, if I am saying that this charge, say A, will repel this charge B, there must be some time lag. That is, if this charge will exert some electric field or some electric force over it, so what will happen? There will be some time that the effect of this charge A will take place on charge B. For example, if I say that there is some lines or some force that is acting over this charge B, it will go like this, and it will get repelled in this direction. But the question here arises is that, is this whole process instantaneous? That is, it happens with like this, that over a second of time it happens. No, there is some time lag, and this time lag is there evident in the epsilon naught that we have seen. Yeah, that is the permittivity. Do you remember what permittivity was? Yes, you are right. Permittivity is the resistance that is provided by the medium to the charges or the effect of charge on one another taking place. So, this time lag happens because of the permittivity, or the scientists say that in this time lag what happens is that this medium, if it is a vacuum, then it is an exception, but if it is some other medium, then what will happen is that there will be some energy that will be stored in the form of electromagnetic waves that will propagate from the charge A to the charge B, and while the time it will propagate, nothing will happen. So, once this electromagnetic wave will reach from this point to this point will be displaced, or this charge will exert some force in force of the electromagnetic waves. It will reach here, and what will happen? The charge B will be repelled. So, this is the concept of the electric field, and how do we find this concept really very useful in the field of electrodynamics, that is the electric charges which are moving. Although it is not there in the concept of electrostatic, but it is very useful when we go to study further the properties of the electric charges. Now, so what we have discussed today? have discussed the concept of electric field, what exactly electric field is, how it happens, how it affects the other charges or the other forms of matter present around us. We even came to know about the practical aspect of the electric field in our life. That is, I considered the example of my parents in my home and me being the test charge which will come into the authority of my parents, that is the bigger charge, and then they will control my behavior. Also, we formulated the mathematical treatment of the electric field E. We also came to know about the spherical symmetry that was found in the concept of electric field E, and in the end we provided some points of why electric field E was introduced in the concept of dealing with the charges and how it is useful in the field of electrodynamics. Now, since we have studied the concept of electrostatic forces, that is the Coulomb force, and the concept of electric field E, we will be studying a very good concept that is called the concept of electric flux. Now, since we know that electric field is something that always point outwards for a positive charge and point inwards for a negative charge, we will find out what exactly the entity electric flux is, how it affects the other charges, or if there is no charge at all, how it affects the vicinity of the charge that is taken into consideration. And then we shall be giving a brief overview of the law that governs all these parameters, that is the law given by Gauss. Thank you.